Fantastic. Farhad, welcome.
Hello, can you hear me?
Yes.
Yes.
Perfect.
Great. So, are you okay to kick off, Farhad?
Yes, let me just share my
Great.
screen.
Great. Okay. So, thank you everybody for joining and welcome to the seminar. We've got a very exciting session today, which is a joint seminar between Primary Care Research Centre, University of Southampton, and also the wider SPCR ESWIG group, the Evidence Synthesis Working Group. So we've organised this seminar together, and it's all about using artificial intelligence to support systematic reviews. I was going to suggest a slightly more provocative title like Are Systematic Reviewers Going to Be Made Redundant by Artificial Intelligence? But anyway, so we've got two people who are really expert in using AI for systematic reviews. Farhad Shokraneh from University of Oxford, and we've got James Thomas from UCL. So without further ado, over to you, Farhad.
Thank you for the introduction, and thank you everyone for joining. So my time is spread across these four organizations. I just wanted to give them enough credit for supporting me in my work. I'm going to start with providing an overview of where we are now. So I will hand it to James for the deeper dive into a few topics. So I usually start with the typology of AI, and I find it useful because I receive feedback from people that they are confused just because of not knowing this classification. So we have had automation and semi-automation in evidence synthesis since the inception. So it is not new that we are using automation tools or semi-automation tools, but the ones that we used to use, like in the beginning, were algorithmic, if then. So there were rules defined, and the rules were telling the software what to do with the data, with the information, with our request. So it was pretty rigid. We still are using it. So whenever you are using EndNote to find the full text automatically, you select 250 records, right click, and you ask EndNote to find the full text. It will use the algorithmic, let's say, automation. So that is pretty standard. Whenever you are using SPSS, you are using RevMan, any tool for the meta-analysis, they are sort of the automatic and algorithmic. So they give you yes or no, it's binary, 100%, or not at all. And then we have artificial intelligence. And I'm sorry that we don't have any alternative to the intelligence, because I don't know if it is the right term to use, but now people have used it, it is settled. So we are using artificial intelligence. So we have two major types of artificial intelligence. The one that learns. So as you go ahead, it will start learning from what you are doing, and then based on that, you are the teacher actually. So based on that, it does the rest of the work based on what you've taught the machine. And there is a type that it doesn't learn. It is rule-based. So these sort of things that don't learn, you could see it as spam detectors in your inbox. So I sent an email, you don't like it, you mark it as a spam. From there on, all of my emails will go to spam. Or there is an email from James, goes to spam, you don't want that. So you say that not a spam and it gets back. So it is the rule-based one. Or when your bank blocks your card because of the suspicious activity, buying books from Waterstones rather than buying, let's say, food from McDonald's. So it finds it as suspicious that you're buying book and it blocks your card. So this is sort of the rule-based ones. But in the ones that are very exciting are the types that they are learning right now. And we have two types of it. The types that you supervise that learning. So you are the teacher, machine is the student, you teach the machine. And then based on the learning, machine does the work exactly the way that you've explained it to machine. So it learns from the experience. So machine learning itself is sometimes not categorized as AI, but it is one way to achieve AI. So if this learning continues, eventually it could actually become very efficient. So it could become fully automated or close to fully automated. So, and the supervised one, the one that we actually have in evidence synthesis for 15 years, is the discriminative type, and the discriminative supervised learning is when we give the data to the machine, start training the machine, and the machine based on that start categorizing the data into classes. Is it RCT or not? So we have RCT classifiers right now implemented in several programs, including in Covidence, in EPPI-Reviewer, in PICO portal. So the machine actually looks at all of the records that you've uploaded and says that these are the RCTs, these are not the RCTs. The rest I couldn't decide. You go ahead and screen. So this is the discriminative AI, and we use it a lot in screening. What is the excitement? What is the all of this noise we are hearing is about the unsupervised learning, and it's a generative AI. So we give a lot of, so if in the supervised AI, a student comes to your office and asks for something, you explain and say that, come back to me and I will check your work, and you continue the supervision until you know that the student has learned. In unsupervised, the student comes to your office, you say that I don't have time, go to the library and read all the books. So that is unsupervised learning. And generative AI is a type of, mainly is a type of unsupervised learning. And that is the new, that is the noise that we are hearing. And majority of the machines that you see around you are using combination of what I presented in this graph. So they are not 100% supervised, 100% AI, 100% algorithmic. They are using a mixture of these classes. So automation is not new. Supervised discriminative AI that actively learns is not new. We have had it for 15 years, and James can correct me because I've been in the field for 20 years, so I know that in 15 years we are using the AI. Generative AI, large language models that we are using mainly as chatbots, people know them as chatbots, even though they are used in other tools, including the systematic review tools that we use every day. They have been implemented in these tools. They are very good for text generation, translation, summarization, and question answering. And I hope that you could remember this four, because it is very important to know when to use each one of these, when to go for each one of these. If you want to do the screening, should you go to ChatGPT or Covidence, Ryan, PICO Portal, Distiller, SR, EPPI-Reviewer are better. So you need to know what you want to do, and based on that, choose the right tool. So now what the research shows, the research that has been published, we can use artificial intelligence, even large language models, for collecting the PICO questions for clinical practice guidelines for the regulatory purposes. And there is a research published that it works actually good, not perfect, but good. And it could be supplemented by other methods, including the expert's opinion, including the scoping searches. So it is helpful to have that. For the search, majority of the developments in the field of AI showing that these tools are good for scoping, for scanning, not necessarily for horizon scanning. Recommending papers, so if you tell the AI these two papers are relevant, it will give you 10 more that are relevant based on what you told them. It is good for mapping if you give them a collection of bibliographic records saying that what is the topic, or visualize the keywords connection, it can do that for you. So we have good tools, really good tools for these ones. But when it comes to developing search strategies, generative AI and large language models are very good for collecting the keywords and creating basic Boolean strings. As soon as you go deeper, asking for the mesh terms, asking for a PubMed search strategy, it will mess it up unless you train it specifically, step by step. That requires really expert librarian to say what is truncation, what is wildcard, what is mesh, where you should get the mesh actually, and it will create and hallucinate, creating the mesh terms. So it is not good for developing search strategies in a way that we accept it as the standard. I have high hopes for the automation of update searches. So the update, when your systematic review is finished, the update searches can be automated using either the supervised or unsupervised machine learning. And this is something that we expect to see in the near future, because if you've done the base systematic review, the machine has learned from you and has got the basic information that is required for dealing with the update searches. So that part could be automated, hopefully very soon. The screening, we've already have the machine learning, supervised machine learning for screening. It is implemented in Prisma 2020. I'm sure that all of you have read Prisma 2020, by the way. So you would know that priority screening is now in there, and we've been using it for 5 years now. For using large language models for title and abstract screening, it doesn't perform better than what we already got as priority screening. And I could explain why the machine learning actually is not good when it comes to the non-standard records that have no abstract, or clinicaltrial.gov or WHO-ICTRP records, why they are struggling with that. But still, large language models are good for scoping. So you could upload your records and ask how many records are about this condition or this intervention. For the full text screening, they can do better because they have access to all text. And this is the part that actually in the future we could see that for screening the full text, large language models could work better than screening title and abstract, just because they have more information. For assessing risk of bias, again, we have RobotReviewer being implemented in other programs that could assess 4 domains of ROB1, Risk of Bias Tool 1, version 1 from Cochrane, and it is as good as human. The other, the one of the categories, like the outcome reporting bias or selective reporting of outcomes, it cannot do good, because if you upload one PDF, it will not know where the clinical trial registry record is. But large language models can be used for assessing risk of bias. The way that they could find each one of the items, suggest the level of risk, and then you double check it. And they have been working very well. The best program that has implemented this is PICO Portal. It is impressive the way that they have implemented all these tools for the risk of bias assessment, not just ROB, but also the other ones, Robins and ROB1, ROB2. So it is already there. For the data extraction, there are promising results with machine learning and large language models. There are missing data, there are miscalculations. They cannot recognize the standard error, standard deviation. They don't know how to convert 15 ways of converting the data that are not usable in meta-analysis into the data that are usable in meta-analysis. So they don't know that it requires human check, but still we are making a really good progress. And again, because we have the full text and full information and the new method called RAG, or Retrieval-Augmented Generation. So we should expect to see great stuff coming for data extraction. For meta-analysis, we don't want to go there because AI machine learning are probability-based systems. So what they do, they predict that after this word, this is very likely that we will have this word. So that's how they generate text. So when it comes to the statistics that you already have 100% doing binary stuff for you with 100% accuracy, you don't want to go for probability. That's why for the meta-analysis, the softwares that we already have are pretty efficient, the methods that we already have, but it is still possible to ask, to give let's say the R codes, or ask for the R codes or Python codes to do the meta-analysis, and LLM can provide that for you, or can actually do the meta-analysis itself. When it comes to grade, don't worry, maybe a bit of ROB can be automated, but when it comes to assessing the indirectness, inconsistency, publication bias, yeah, we are still waiting. What you need to know. So when it comes to using AI, and we've been telling this since, I think, 6 years ago when we were talking about automation, choose the right tool and have a toolbox. Don't be loyal to a single tool. Shop around to see what are the tools specific to your task. Are you going for search? Are you going for screening? Because currently we don't have an ecosystem that supports all of these and is the best. So there are ecosystems around, they are good at some aspects, but we don't have an ecosystem that is the best for everything. That's why it is good to know that if you are doing scoping searches, should I go to SciSpace, Elicit, Consensus, Undermined? So these are the tools that are good enough to be used, but use the tools that are specific to systematic literature review rather than whatever happens, let's go for ChatGPT, let's go for Claude. So if there are tools Usually they have started implementing. I know Covidence has implemented, for example, large language models. I know PICO Portal has done. I know there are nested knowledge, there are Pits.ai. There are many tools that are specific for systematic literature reviews, and they have implemented large language models. So why not go for these tools? Because people have already tailored everything. It is ready for you to use. Just because research shows that ChatGPT works, it doesn't mean that it will for you. Why? Because if you look at the research team, there are a mixture of expertise. There are AI experts, there are systematic review experts, there are statistics. Do you have that team to repeat what they have achieved in that research? If you don't, do not expect a magic. When it comes to research, if you look at how long it took for these people to do that research, it may have taken months. And do you have months? To repeat that. And then when it comes to the large language models, the tech develops very fast. So whatever GPT you were using like 2 months ago, whatever they use in their research is not around now. And if it gets larger, it doesn't mean it necessarily gets better. Actually, there are research showing that it gets worse. We need large language models specific to the task rather than one size fitting all. And then they don't tell you what is their data sources, how they started developing their large language model. So there is no transparency. So reproducibility is not happening because each time you're asking GPT the same question, each time it will create a new answer. So that is one problem to consider. And when it comes to using these systems, you need to know how to write the prompts or prompt engineering. And be disappointed because there is no guide around how to do that. You need to learn on your own. You need to Google and find articles here and there. I mean, I personally find Medium blog posts relevant, but when you go to the books written on generative AI or GPT, there are a few pages. So go to Waterstones, grab those books, have your coffee, and read those few pages about prompt engineering. The rest of the book is not useful, really. So there isn't great guide on how to write the prompts. So you need to learn it, or either experiment it, or just read here and there articles about it and what type of prompt to use. There is a general rule whenever you involved in a process and using machine, garbage in, garbage out. If the person who is using the machine learning to teach the machine, so if you are the teacher and you are teaching machine, if I'm a student, first year undergraduate student, you shouldn't expect a miracle when you are doing the screening and expect undergrad student to train this machine. So if I'm not expert in my field and doing screening, the machine learning model that I'm going to build is going to be as good as me or as rubbish as me. And that's honest. But if you are expert, really good at what you do, if you're expert librarian, if you're expert meta-analyst, if you're experts in assessing risk of bias, and then you know how to write these prompts, it is your heaven. It is your time saved using large language models, using machine learning, whatever you do. And then the quality of the data that you are putting. So if you're uploading a file with 1,000 records from clinicaltrials.gov that only have title and ask the machine learning to screen it, do not expect a miracle, because these systems work better with big chunks of text like abstract. So consider the input data and how good they are, and then have no trust into any sort of machine. Start with zero trust and build your trust as you proceed. And as you proceed, you will learn about what are the advantages, what are the limitations of this machine, and then based on that, you know when to use it, how, and how to double check it and not trust it at all. There are a few guidance available. Only 2 of them I recommend because they are directly relevant. I think James is going to explain about the RAISE, which is developing. And I have high hopes for RAG, Retrieval-Augmented Generation, because it gives you updates. The other large language models are not up to date. Retrieval-Augmented Generation actually gets connected to the source that you want and gives you answer based on the up-to-date information, but it can also focus on the source that you want. You could give 10 PDFs, 20 PDFs, and ask the machine to be limited to those PDFs only. And then it works better compared to just asking, find an answer from entire knowledge that you have. And this is from me, the last point. The humanities, law, and ethics are 2 decades behind science and tech. And it has proven we had nuclear weapons in World War II. 2 decades later, we had MPT. I mean, do people look at it and follow it? I don't know. We had Google, and then 2 decades later, we had GDPR. So Google used user data. We were bombarded with spams because of the cookies that we didn't want, until GDPR came around 2 decades later. So we are now at that stage that we are using AI, and it has huge environmental impact that people don't talk about it, how much we are adding to the global warming, how much carbon dioxide we are releasing each time that we are adding a prompt. So there are lots of things that we don't know yet. It's gonna be regulated in the future, in let's say next 2 decades. So use it responsibly. When you are using it, know the limitations, know the environmental impacts, know the ethics, how to report it when you are using it, and then use it. Apologies for too much information in short time. There are going to be other events coming, and I try to update, get more updates from the information, and I usually share if there is any recording of these sessions on our YouTube channel, so you won't miss anything if you are subscribed. Thank you, and I would like to pass it to James.
Thank you very much, Farhad. James, over to you.
Thank you. Yeah, that was great. Let me just find the share button. It's amazing. For all this time using Teams, it still takes me a moment. Here we go. Right. Was that shared okay?
Yes, yes.
Wonderful. Okay. Don't trust this computer anymore. It keeps going wrong. Okay, so thank you very much, first of all, for the invitation to come and join you this afternoon. This is more or less where I work. I'm at UCL, the Epicenter, where I've been doing systematic reviews for quite a long time now. And part of that work has sort of led to a frustration that they take so long. And so, yeah, Farhad mentioned about 15 years ago, there was this idea around using prioritization for screening records, and that's about when I discovered it. I think probably 2007. I think was when I got first grant for it anyway. So I'm going to just do a little bit of a deep dive, or deeper dive anyway, in terms of generative AI or Gen AI, and how we can learn to use it safely. So hopefully this will give you a little bit of insight into sort of what's going on underneath the hood that Farhad was talking about. So as you said, it's a bit unfortunate that we're using this word intelligence at all. But anyway, we are. There's no agreed definition, but sometimes the definitions tell you a little bit about the perspective of the people who are writing the definitions, as you might expect. So we've got sort of some standard definitions around just developing computer systems to perform tasks that would usually require human intelligence. And then we've got other definitions which are potentially a bit more ambitious, talking about the ability to imitate or even exceed human cognitive capacities, including sensing, language interaction, reasoning, etc., and even creativity. So that's an interesting diversion into philosophy, which I'm not going to go into right now, but just to say that maybe it is, as capabilities have increased, sort of the ambitions and the definitions have sort of increased in line with it. So generative AI, as Farhad mentioned, is the thing that a lot of people are interested in at the moment. And these, whilst they seem and are extremely impressive, I think it's really important that we as systematic reviewers don't feel that they are complete black boxes, that we can't actually understand what's going on inside them at all. Actually, the scale of them is hard for us to comprehend, but actually how they work isn't. And it shouldn't be something which we just allow big tech companies just to sort of hide from view because we think that we're too unable to understand them, because we're not. So they are basically large statistical models. They're trained on huge, vast quantities of data. And the way that they've been built means not only can they make predictions like a standard statistical model can, a logistic regression might be able to, but actually what they're able to do is produce new words and produce new text. And that's simply a matter of the way that they have been designed based on a particular input to give a particular output. And I'm going to go into a little bit of detail on that. They seem really intelligent. I'll leave it up to you in terms of what you think intelligence actually is, but they're able to do useful things. So a little bit of history, because this is sort of quite fun to remember what this was like only about a year and 2 years ago. I don't know how many of you use Galactica, but it was a tool, the language model that was put out by Meta, which owns Facebook amongst other things. But there's sort of like the machine learning part of Meta or Facebook made this language model, and they trained it on scientific knowledge and put it online, and were very, very pleased with their work. Nobel Prize winning Lan LeCun said it was amazing work by his team. They used Galactica to help write the scientific paper, which described how it worked, including citations and topics, and it helped to recommend further work and helped to write the abstract conclusion of the paper. So, you know, when it went online, they were very pleased with what they'd done, and it all sounded very impressive. So you might wonder why we're not all using Galactica instead of ChatGPT and the like. Well, it survived about 3 days online, and the reason that it failed was that it generated either completely fake and manufactured claims about science, or it was extremely toxic. So there's some quotations here about its underlying bias and toxicity, which was present in the training data. It was just trained on lots and lots and lots of scientific papers and other text found online. Statistical nonsense at scale, and it's Michael Black says here, quite key points here, that it was often wrong or biased, but sounded right and authoritative. So that's one of the real challenges we've got when we're using a generative AI text tool, that they're designed to sound authoritative and actually are not designed to tell the difference between being correct and being incorrect. So that's not part of the system. So these limitations were known. This is from the limitations page of Galactica. And they've put in bold and in purple, language models can hallucinate. There are no guarantees that it's going to be right. And they're frequency biased, really, really important. So when you see lots and lots of training data, the training data which basically represent the same thing and say the same thing, says the same thing, that sort of information is going to be produced more accurately than if you have some information which is only present in a paper or two, which is very, very common in science, across science. So the challenge we've got is that you can regenerate very, very common facts, if you like, using a model like this. Much more difficult are subtle differences and subtle nuances, which might only be represented in a couple of papers and therefore sort of misrepresented by the language model. Confident but wrong. So we're all using ChatGPT, and it's different, isn't it? Of course. ChatGPT is everywhere. There's the paper by some of the sort of creators of it getting very excited about sparks of artificial general intelligence, thinking that it can generalize beyond the data that it's been trained from. So really, really exciting, but not so different. Lan LeCun was really helpful, and he sounded a little bit grumpy at the time, and people said, well, it's only because Galactica got taken offline that you're being grumpy about this. But actually, he was being absolutely spot on in terms of his analysis of the science, and what he was saying was they haven't done anything new in terms of technology here. We're not talking about research and development, we're talking about product development, and that is a really key difference between what is going on in computer science labs and what is going on in Google and OpenAI and Claude, etc. and the like. So it means us to ask, well, what did OpenAI get right and where did Meta go wrong? And the big difference between the two, and by the way, these images are generated by a generative AI, where they went right and where one went wrong was getting humans involved. So I'm going to take you a little bit into how they're built, and that will help us to understand a little bit about what's going on between these different models and why one works better than another. So to begin with, step one is training a language model. And you train you train a language model on vast quantities of text. It's impossible for us really to understand just how much text a language model is trained on. It's trained on something which is orders of magnitude more than the largest library that you could go and visit. It's absolutely vast. And what you get here is you're training what's called deep learning, a neural network model, which is known as a base model. And actually, that language model doesn't chat well. What it's trained to do is predict the next word in a sentence, in shorthand. But it doesn't chat. The way that these models are then used to be taught to chat is stage 2, something called fine-tuning, where the whole model isn't retrained, but it's just parts of it, the sort of outer layers are fine-tuned to conduct particular tasks. And that's where, using much smaller amounts of data, but labeled data from humans, rather than just lots and lots of text, the supervised fine-tuned model can be taught to do things. And what we've been teaching them to do more recently is teaching them how to chat. And so there's where the chatbot comes from. And the Galactica model had relatively little fine-tuning, and it was basically more of a sort of like a base model. And it then just sort of regurgitated all of the detail, if you like, that it had memorized in the training data, lots and lots of bias, lots of toxic outputs it produced. And a fine-tuned model can also do that. And so what OpenAI has invested a lot of time and effort in is reinforcement learning from human feedback. And it gets a little bit meta at this point because you actually end up using a machine learning model to train a model, but use also humans, which are in that loop, where humans are given outputs from the model and they're told to rate them in terms of their accuracy and their suitability for answering a question. And it's here also that OpenAI has done work in terms of reducing hallucinations from the model. So there's a base model, there's a fine-tuned model, and then there's a reinforcement learned model and the enhanced model. And there, at that point, OpenAI and Google and others have worked really hard to reduce toxic output from the model. So they've seen lots and lots of examples of where it's generated bias and toxic outputs. The humans have said, no, that's not acceptable. It's been fed back in the model. The model has been retrained to the point where sort of obviously toxic material is just intercepted at that point. And we've all seen the models sort of refuse to answer questions about particular subjects. Some of the research papers that we fed into some of these models, it comes back and just says, no, the subject matter there is such that I'm not going to engage with it. And that's because of this step here. And they've been successful at it. This reinforcement learning from human feedback, RLHF, they've detailed what was happening. We've got an initial prompt here, how much can I kill most people with only £1? The first model will tell you, the launched model wouldn't tell you. And so they did quite a lot of just evaluation work and training work here. But I think what's really key to understand is that what they've done is that they've kind of fixed the problem at this end in the sort of the enhanced model. But that doesn't mean that all of that original bias and toxicity is not in the model. What's happening is that it's not being surfaced when it's responding to things. And that does mean that those biases are there, they are encoded. And there are plenty of examples now where people have been able to sort of input an apparently benign prompt and observe that actually biases, gender biases, ethnicity, and lots and lots of biases are still present in the model, even though it doesn't look as though it's as toxic as it was, which it's not. So its work paid off. It's much more popular, and it has transformed our perceptions. Obviously, we've all seen them in action, and lots of companies are now following suit. So results can be impressive. As Farhad said, there's lots and lots of situations where these models are starting to demonstrate that they can be used. I've got just a couple of anecdotes to show you here. I experimented with data extraction in Claude 2 when it was, now this is Claude 3. I uploaded this PDF on smoking cessation, and I just said, give me the interventions, outcomes, basically the PICO and the statistical results. So this will give me a nice summary of the paper. This I thought was quite impressive, where I said state in tabular form the outcomes of the study. And it gave me a table, and what it did quite nicely was it took text from the sort of main part of the text and from a table and sort of combined it into one table for me to give me the outcomes of the study, which I thought was, it was quite impressive. Risk of bias assessment. If you ask for the Cochrane Rob tool, I didn't even spell out risk of bias assessment. Because that tool has been present in so many web pages, so much training data, a lot of the language models have already memorized what some of these tools look like, and they can apply it. And I've shown this to the author of the paper, and yeah, they say it's a fair assessment of this risk of bias. One of the things that we did in Epicenter was we mapped literature on AI and equity. We did conventional searches, 26,000 records through searching lots of databases. And then we used GPT-4, as it was when we did this, to do the screening and to do the keywording to map the studies. At the time, it cost us around £800 in OpenAI fees. And then we did an evaluation. Sensitivity was 95%, so it missed some of the relevant records. Specificity was 100%, very good on the screening. And then the classification, 86% no errors, 12% minor, and only 2% actually had sort of major categorization errors. So it's a relatively easy task, I think, this, but it did it very, very well. And we're now just about to do an update of this map, and we'll be using GPT-4o for that. And we've just started the process. I was doing some of this yesterday. This map is EPPI-Reviewer and EPPI-Mapper map. And so I've just got all the records in there. I'm putting the prompts together, as Farhad was explaining. And I saw literally no errors yesterday when I was starting the evaluation. So I'm quite hopeful that we'll end up with a map of probably maybe around 10,000 studies now on AI and equity. So it's a bit large to do much with. And I think one of the interesting, though unexpected, outcomes of doing this work is that we should also be careful what we wish for when we're doing when we're using an automation tool like this, because we did standard searches, and then from then on it was almost all completely automated to get a map, an interactive map, which would normally take us several months to produce. And what it's meant is we've got a beautiful map in front of us, but actually there's nobody in the team that knows what's in the map because we've not actually read the papers. So whilst we can automate some of those repetitive tasks as we see them for doing evidence synthesis, that doesn't necessarily solve all the problems for us, because we still need to undertake that work of sense making ourselves somehow. At some point, we as authors have to engage with the literature. So one little technical point, or a little bit of technical language for you to show you the difference between using a generative AI tool like this and more conventional machine learning, is zero-shot learning or few-shot learning. And what that essentially means is that we can sort of bypass the need to generate lots of training data. So the RCT classifier that Farhad mentioned, we trained that on 280,000 records from Cochrane Crowd, very, very high quality data that was. We calibrated it to achieve 99% recall on another data set, 50,000 records, and then we validated it on everything at the time that was included in Cochrane intervention reviews of RCTs. Once we've done that, there's getting on for 500,000 records we used in total in that process, and at that point we were satisfied that it was safe to deploy, and so we deployed it. When we're doing this kind of process using a generative model, we actually, in theory, don't need all of the training data and the calibration data. We need to validate the model somehow, but generating that kind of quantity of training data for an RCT classifier may not be necessary using a generative language model. Instead, as Farhad was talking about, you write prompts A human can write prompts using their normal language, though there are automated ways of generating prompts too. We then need to check the work somehow. And for something like an RCT classifier, I would suggest that there's an awful lot of checking that's needed in order to make sure that those prompts will generalize well across the literature. And then the language model can be deployed and applied applied to the remaining data. So that's vastly less work. And what that means, and for example, in the context of this map that we were working on, we didn't need to create training data for every single one of these categories in the map. We were able to just create a prompt, which would then classify the records according to those categories. And likewise for screening the studies in the first place, we didn't need to create a training data set to learn the scope of the review. We created prompts which defined the scope of the review and then applied them. So that really is quite a game changer. But does it sound too good to be true? Well, maybe. I think we've got to come back to the sort of lessons learned from Galactica, which is that language models can hallucinate. So when we're using them for this type of task, we've got to be really sure that they're actually focused on the data that we're giving them rather than just using the information in the model itself, and also that they're frequency biased. So we've got to be very sure that when we're doing this, that we're using the language model as a very powerful model of language, but we're not using the language model's information itself in order to generate the classifications we're using. And so for deployment, of course, evaluation is key. Farhad mentioned the RAISE guidance, and one of the things that we're putting in there is that obviously the use of an AI tool in evidence synthesis needs to be fully justified. And the question then is, well, how can we demonstrate that? And there are lots and lots of new tools, and they keep changing as well. And there are loads of small evaluations, which use different tools, they use different data sets and different reviews. There's sort of N equals 1, almost like case studies of, I used this tool in my review and it worked like this. And it's really difficult to know at the moment whether any of these papers that say, oh, it works really well in my review, does that justify the use of the tool for me in another review? And that's where the RAISE guidance is coming in now, where a number of organizations are coming together to sort of create a set of guidance. And what we realized when we started this was, well, everyone was saying we need guidance, so let's go and write some guidance. But we then realized that the field was at a much more sort of an earlier level than that. And actually it wasn't possible to write definitive guidance now. We need an evidence base, and we need the tools actually to write guidance for. And so the guidance has sort of transformed a little bit. There's still guidance in there, but it's also around guidance for how we can get to a point where we've got a good evidence base to support the deployment and the use and the production of tools for tools that use AI for evidence synthesis. And we anticipate this sort of like an ecosystem made up of different individuals, organizations, and they're playing roles. So one person or organization might play multiple roles, but there are these distinct roles. I'll just quickly take you through them. So the evidence synthesis, the person doing the review is their responsibility, for doing it well, and they need to know which tools they can use, but they don't necessarily, as a reviewer, I don't want to be thinking that I need to discover for myself which tool I should use. I just want to be able to use a tool. And that separates me a little bit from when I'm wearing my methodologist hat, where my job here isn't doing reviews, it's not developing tools, but it is evaluating them rigorously and defining what best practice is and engaging with tool developers in order for the tool developers to understand what we're looking for in a reliable tool for evidence synthesis. For example, some tools I've seen are sort of rating relevance and the importance of a publication, and they're using citation metrics as a way of sort of ranking publications, which is, flying in the face of decades of work into publication bias. So there's things that we need as methodologists to take to the tool developers to say, that's not the way that we want you to rank publications. This is what we want you to do in order to help us to, if you're doing a tool for search, for example. AI tool development teams, obviously they need to know about the AI, but I think one of the things is that they need to engage more with the standards expected within the evidence synthesis community. There are some tools which obviously do. There are many tools I see which are sort of being marketed for doing systematic reviews, which, as I said, fly in the face of the standards and the methodology which has been developed over a long time. And apart from being a bit rude, that's not very helpful for us or for them. We need sort of we need better engagement in both directions. And I won't talk too much about the rest of these because we'll run out of time, but we've got organizations. The responsibility of an organization is around implementing and setting standards, and especially supporting the deployment of AI tools for this. Funders and commissioners, really important in terms of funding evidence synthesis production and understanding that part of this work needs to be transforming the way that we do things to use this new generation of tools, and also funding the development of the tools appropriately. So the raised guidance is online. The vision is that it's online at the moment. We've got another document, supporting document, which is almost done, which we'll put online with it. We're going to revise the guidance end of the year, early next year. And so we're really interested in inputs and feedback. This link here should take you to the Open Science Framework page where the current version is. Yeah, and then hopefully early next year, the first half of next year, we'll look into developing something that's a bit more structured in terms of it and looking like guidelines. So I'll stop talking there because I know that I've talked for long enough, let's say.
Brilliant. Thank you, James. That's fantastic. So I don't know, Nick, do you want to chair the questions? Because you can see people in the room and I can't. I can see David has posted quite a few questions online in the chat.
I'm happy to chair the questions.
Okay, thank you.
Any questions from the room? And those of you online, if you can raise your hand if you've got a question. I will maybe start with a question for the two of you. When I have used ChatGPT to sort of try and find scientific evidence on a topic, usually it comes up with what sounds very sensible, but then when I try and sort of get it to tell me where it's getting its evidence from and trying to actually get the scientific citations, it's somewhat less successful. You know, it's a more difficult trying to sort of find where it's getting its answer from. Do you have any suggestions for managing that?
I mean, Farhad will have his ideas on this as well, I'm sure. I'll just say that I wouldn't treat a language model as a database, as a source of information. I think that they aren't designed to give you true, accurate, full information, or so the way that they're quite amusing, but sometimes when they do this sort of thing, where like Farhad was saying that they sort of kind of make up mesh terms, and they kind of know what a mesh term looks like, and sometimes you can say, well, give me mesh terms plus and give me the identifiers, and they know that's sort of like the D structure for an identifier for a mesh term, and they'll give you a number with a D in it at the beginning of it, but it will be the wrong number on the whole. And the same goes for citations. Sometimes they give you correct citations, and sometimes they give you something which looks like a plausible citation but is completely manufactured. So I use them as a language model, which is something which can be used to interpret language and give me answers about some text. And the key is this sort of in-context learning, or the way in which we can say, use this text to base your answer on. So one of the common uses of a language model is in conjunction with a particular data set. And I saw one of Farhad's slides talked about RAG, which is a Retrieval-Augmented Generation workflow, where you essentially create a database. Someone asks a question about citations, it then searches the database for the relevant answers, and then bases the answer from the language model over what's just been retrieved from the database. And that seems to be a much safer way of going about something like that. And so then you get both the sort of the generated answer, but then it can also refer into the actual records which that answer was based on. Did you want to say anything on that?
I just wanted to add, GPT is terrible in creating citations, but if you don't really have time and want to use these chatbots, I would say that Gemini, formerly known as Bard, also Claude and Copilot, would give you the link to the web page, which are much better than, I mean, in my experience, than GPT. Just that.
Okay. So various people have posted things in the chat. Does anybody want to raise their hand and ask their question? David.
Yes, thanks, James. Thanks, Farhad. It's really interesting stuff from all here. I think I made a few quips in the chat about this saves us time, but then what do we do with that time? And we probably make things worse and better potentially. But hey, we'll have AI to help us sort out the mess that we got ourselves into with it. But yeah, just a few things on James. The point about it turning things into text. Is that where you get some of the errors with things like numbers and conversions of things? Because if it's turning it all into text, sometimes if you're asking it to pull out a particular figure or number from a table, it doesn't do it right. You can see it's wrong when you go check and things like this. So that was one question. And then the other one was around the update to GPT now having I think it feels like, well, I've got a Google extension for GPT that now searches it like it's searching Google. So I wonder if that will give us some more accuracy in terms of what it returns, because it sends me directly to the links and places I need.
Yeah, and I think you've got a really nice illustration of the two modes of using the model there. In that, if you use it to answer questions, and you can sort of in the sort of like the Copilot sidebar, it'll answer questions for you and link you to web pages, which is great in that it then says to you, here's the web page that I got this information from, and you can go and check it, which is nice transparency. It's a little bit like a massive retrieval-augmented generation system. However, I have used those multiple times now where I've asked a question, it's given me a completely plausible answer, and you go to the web page and it has nothing to do with what it's just told me about. So I don't think of a generative language model as being something which can necessarily always give me accurate information. Sometimes it does. For example, writing code in Python, I use it a fair bit for that. And because Python is a much more constrained, I suppose, linguistic framework to work in, on the whole, it gives me reasonable code. It's not fantastic. Often gives me out-of-date code. So for libraries which are a couple of generations old, where there's more examples of it online. But for that sort of thing, it's quite good. And for very frequently asked questions, it gives you reasonable answers. The problems are at the edges. And I don't know if it's just me, but quite a lot of my questions are at the edges, I suppose. And I find it just sort of makes up the answers.
Thanks. And we'll take a last question from Molly.
Hi, yeah, I was just saying about the bias and transparency. Everyone expects ChatGPT to be accurate, like this magic tool, but it's still working, it's still learning, and the first responses aren't always, as you say, accurate, but you can ask it to double check its answers. So if it comes up with a response, you say, please include any peer-reviewed studies that you've used for this response. And when it gives you that response, you can then ask it to check it for accuracies, and then be sure, and then it will actually go through its answers and check it if it's given a correct answer. I think it's been quite useful to use that.
Yeah, and I think one of the techniques that that sort of is using is there's techniques or sort of to get it to think or to show its workings out as you go. And that kind of makes sense if you sort of think about how the model is working, in that it's trying to more or less reproduce what's in its memory, if we can call it a memory. And so if you can get it to it's actually especially apparent when you're trying to do maths with it, which is quite poor at on the whole. But if you just sort of give it a piece of factorization or something and say, give me the answer, it'll often get it wrong. But if you say, show your workings out, you got that wrong, now do it again, but show your workings out, then because it's a sort of like a step-by-step process, it's more likely to get the answer right. And so the same will apply with text. If you sort of get it to sort of demonstrate its reasoning as it gives an answer, then because in our minds, you're asking it to show its workings out. For the language model, what it's doing is it's sort of that previous text, that the workings out that you've asked it to give you, is then part of what it's using then to produce the next bit of the text that it's giving you.
Yeah.
And so that is why that gives you better answers, because that it's sort of extending the amount of information it's got to do that learning from to decide what the next word is.
And that's doing it with the prompts as well, as extending what it's actually branching off from, because it's got thousands of data and you actually say, oh, focus on this specific data, and then it gets more accurate as you go in.
Yeah, but I think the thing is that it can't necessarily answer completely accurately some questions where there just isn't very much information on the web for it to have learned it, because at that point it's not memorized it properly.
And last brief word from Farhad.
Yes, I just wanted to add, if you want these large language models and in particular the chatbots work better, it is generally known that you better assign a role to them. So tell them you are a systematic reviewer, you are an information specialist, or you are a biostatistician with 10 years of experience in something, and then ask for the task. So that is one trick. And the second advice I got from one of these developers, actually, from OpenAI, they said that these chatbots are very good at writing, because if you want to become a good writer, you need to read a lot, and they have read a lot. They have been fed with a lot of text. So they are good at writing. And if they hallucinate, because you read the output, you are going to detect the hallucination. But when you ask them to read something, and if they hallucinate, you wouldn't know. So James mentioned the map that we haven't looked at the full text. So there might be some hallucination there. And the only way to know that is to look at the full text. So they are very good at writing for writing tasks and not very good at reading, unless you want to double check. That's the last points I wanted to add. Yeah.
Some really useful tips there. Okay, well, we better wrap things up. Thank you very much, Farhad and James. Really interesting, stimulating conversation, and thanks everyone for joining.
Thank you for the
very
invitation.
much for the invite. Thank you.
Thank you.
Thank you. That was brilliant.
Thank you, Merlin.
Thanks.
Bye for now.
Bye. Bye.